Here you can see a little bit challenging function, Boolean implies function. So basically the idea is such. So basically I could come up with like real life ideas, real life examples, but I just want you to remember I just want you to understand the formula. Here x is precondition, y is consequence, and a logical implication is false. That means the result is false only if the precondition is true while consequence is false. The result would be 0 when the x is 1 while y is 0. In other cases it will always be 1. Here you can see 0 0 x, this is 1 because you can see x is not 1 while y is 0. Here both of them 0. Here you can see x is 0 while y is 1. It will also be 1. Here you can see x is precondition and this is 1 while y is 0. And according to our rule, a logical implication, in other words the result is false only if the precondition is true while consequence is false. Therefore this would be false. Here both of them is true, the result is also true. Unlike Boolean implies function, Boolean equivalence function is easy to understand. So basically the idea here is if both statements are true or false, the result is true. So here you can see both of them is false, therefore the result is 1. Here you can see x is false while y is true. That means both statements are not both true or are not both false. Therefore the result is false. Here again both statements are not either true or false, therefore the result is also true. Here you can see both statements are true, therefore the result is true. Let's see another interesting function, Boolean exclusive OR function. So here you may note that this looks like Boolean OR function, right? Yes, you're correct. But unlike Boolean OR function, where you can like the result can be true if either x or y is true or both of them. But here, unlike OR function, it requires it to be exactly one is true while another one to be false. Here for example 0 0, right? That means both of them is false, but this exclusive OR function requires it to be one of them to be true while one of them to be false. Here both of them is false, therefore x exclusive or y is 0. Here you can see this one is false, this is true, and it matches the rule of exclusive OR function because one of them is false while one of them is true, therefore it's true. Here again it matches the rule because this the one is true, the other is false, therefore it is true. Here it doesn't match because both of them is true, while therefore it is 0. Let's see Boolean not AND function. Here the idea is when both x and y is false, for example 0 0, the result would be true, or when one of them is false while another is true, the result would be true. But when both of them is true, the result would be false. Here you can see x is false, y is false. Therefore the result is 1 because both of them is false. Here you can see x is false, y is true. The result would be 1 because according to not AND formula, one of them must be false and another must be true. Here again one of them is true while another is false, therefore the result is 1. Here both x and y is true, and the result would be false because according to not AND formula, when both of them is true, the result must be false. Finally, lastly, we have Boolean not or function. So the idea here is the result is true when both x and y is false, where we see that both x and y is false. Of course here 0 0 because x is 0 and y is 0, and x is false and y is false. In other cases, for example, here y is true, x is false, here x is true, y is false, here both of them is true. So therefore only here we put 1, while in other cases 0 0 0. Yeah, that's all.